Okay, I'm back, and now we want to do part 3, which is making a magnet. And so in order to do this, you're going to need a battery, and then you're going to need a coil of wire. So here is a battery, and so this is the positive end of the battery, the one that has the nub on there, and then this side over here is the negative. And then we're going to attach a wire to it and then coil the wire like this and then reattach it to the battery. So the simulation has already done this for you, so that if we go back to the simulation, and now we're going to click on this one down here at the bottom. So click on that, and so there's your battery, and then there's the coil, and then you can see the magnetic field that is being created by that battery. Now you should notice that there are some things that are moving in the wire. They're moving so fast it's really hard to see them. So if I take my battery, so here I can change the voltage on the battery over here. Now at this point you don't know what voltage is, but voltage is going to be given by the letter V, is going to be the thing that's going to be pushing electrical charges in the wire. So we don't really need to know about that yet, but I guess now you know about that. But we're going to move this little bar over here, and that is going to lower the voltage. And so now, can you see these blue things that are moving in there? And each of those blue things has a negative on it. So what do you think that they represent? So they are going to be the electrons. So in a wire, the battery is going to be pushing electrons in the wire, and then you can see that they go around and around and around when they're in the coil, and then they go back to the battery. And so one thing you should notice is if I increase the voltage, then that makes the current go faster, or it makes the electrons go faster. Now the movement of the electrons, we're going to call that a current. So just like you have a water current, the flow of electricity, electrical charges, is going to be called an electrical current. And V is going to stand for voltage. It's going to be the pusher that's pushing the electrons in the wire. And then I, so this is a cursive capital I, is going to be electrical current. Now in some textbooks it's going to be I like this, and then in other textbooks it's going to be I like that, but I like to use a cursive capital I to represent electrical current. And so it's going to be the flow of those electrons. Now these little arrows out here, these little tiny little compasses, they're pointing in the direction of the magnetic field. And what do you notice? So you can take this little compass here and you can move it around, and you can map out the magnetic field of a loop of current carrying a wire, and you should notice it makes a magnetic field that is identical to another thing that makes a magnetic field. So if you go back up to the previous part of the lab, you'll find out that the magnetic field of something else looks exactly like the magnetic field of a loop of wire that is carrying electricity in it. Then another thing that you should notice is, look at the brightness. So if I push this all the way to maximum voltage, do you see the brightness of these little compasses in here? And then as I lower the voltage, do you see that they're becoming dimmer? So what do you think? What does that mean about the magnetic field? If I decrease the voltage, the magnetic field is getting what? And then also, I'm going to take this and I'm going to put it on 0. So if there's no voltage, do you see what the electrons are doing? They're not moving. And so if they're not moving, they can't make a what kind of field? All right, so these are little questions that you're going to be answering in the lab that has to do with this. And then I also ask you the question about the magnetic field of the Earth. So if you go to the internet, you should be able to find a picture that shows the magnetic field of the Earth. And then what you should do is look at where is the north geographical pole of the Earth is really a blank magnetic field or magnetic pole, which is something that you might find kind of unusual. But it really does make sense because the north end of a compass always points north, but it's really pointing towards a magnetic pole that's up there, which is the reverse of what you might think it should be. So answer those questions in the lab. Okay. All right, we're going to take a break. And when we come back, we're going to do electrical generators.